Hello dear students, this is your Jagan sir. Welcome back to our YouTube channel Physics with Jagan sir. And today we are going to discuss fifth class in our work energy power chapter, and the topic name is potential energy. And before we are going to see potential energy as a topic, let us first go through with conservative and non-conservative forces. See, suppose the first point is conservative forces. Conservative forces means, suppose an object starts its journey from this point and it traveled up to a location, and here again coming back to its original position, and the total amount of work done is equals to 0. If total amount of work done is equals to 0, then we can say that the force which makes total work done to be 0, that force is known as conservative force, right? Right. Next one, and I will give you an example. Next, I am giving you an example. Suppose here an object is present. This object is moving a height h. Suppose the object is moving a height h. Now, work done by gravity becomes work done by gravity for upward journey. For upward journey, work done by gravity is equals to mg is acting in the downward direction. This is the force due to gravity which is acting in the downward direction, and the displacement of the object is in the upward direction. So force dot displacement, and here we need to do dot product, and force is mg and displacement is h, and the angle between mg and h is 180 degrees, 180 degrees, which is equals to minus mgh. This is the work done for the upward journey, right? Work done for the upward journey. Let us see for the work done for downward journey. Work done for downward journey, then wg force dot displacement mg s is equals to h cos 0 degrees, cos 0 degrees, right? Then here mg is in the downward direction, h is also in the downward direction, then it will be mgh, work done by gravity is equals to mgh, and this is for downward motion, then the total amount of work done here, mgh for upward journey minus mgh, for downward journey plus mgh, and total amount of work done is equals to 0. So here the force which makes the complete journey means for upward motion and downward motion, only one force is using here. That force is the gravitational force. So we can say that gravitational force is conservative force, right? Then second point, non-conservative forces. Non-conservative forces, here non-conservative forces means suppose object starts its journey from one point to other point, again coming back to the original point, but work done will never be equals to 0. In such a case, we consider which force we are considering. That force is non-conservative force, and we will see with an example. Suppose an object of mass 1 kg is present, and coefficient of friction between the two surfaces is 0.2, let us assume. Then work done by frictional force for the displacement of 3 meters, let us assume 3 meters displacement taken by the object, right? Then work done is equals to friction will act in the backward direction, displacement of the object is in the rightward direction. For for rightward motion, rightward motion, right? Work done by friction is equals to frictional force into displacement, and this will be n, this will be mg, right? And friction is displacement and friction are opposite to each other. So we can write Fs cos 180 degrees, which is equals to minus Fs, and F is equals to, we know from our previous classes, N minus mu mgs, and mu is equals to 0.2, mass 1, 10, displacement is 3, which is equals to 6 joules, which is 6 joules. I hope I am very clear from my side. And the next point is, let us say similarly block is moving in the leftward direction, same displacement 3 meters, and friction will act in the rightward direction, because object is moving in the rightward direction, means leftward direction means friction will act in the rightward direction. Right. Now again work done by the friction is equals to F dot S, then F dot S cos 180 degrees, because friction is acting in the rightward direction, displacement of the object is in the leftward direction, which is equals to minus Fs, then minus mu n s minus mu mg s. So which is equals to work done by the friction is 0.2, 1, 10, 3, which is again equals to minus 6 newtons, minus 6 newtons. Now total work done is equals to, total work done is equals to work done for the rightward direction plus work done for the leftward direction, and work done for the rightward direction due to the friction is minus 6, and for the leftward direction is also we are getting the same result, minus 6. So obviously the work done by the friction for the complete journey is 12 joules, which is not equals to 0, which is not equals to 0. So we can consider frictional force is a non-conservative force. So we can consider, therefore friction is a non-conservative force. Friction is a non-conservative force, right? I hope you might come to know exactly what is the difference between conservative forces and non-conservative forces, right? Let us go with the next concept, potential energy. Potential energy. See here, I would like to tell you this with the example. With the example, see here. Suppose an object is present at this location. An object is present at this location, and let us assume we are given a kinetic energy of 150 joules, which is equals to half mv square. We are giving certain amount of energy to the object. Because of that energy, the object is moving in the upward direction, and probably it might reach up to this location, probably it might reaches that location. And let us assume a point, if the object is again coming back to the original position, again it should possess 150 joules of energy, and object started its journey and going in the upward direction, and ultimately I told that the object comes to here and it is rest position at this point. At this point, if the object is at rest position means, can I say its kinetic energy, which is equals to half m0 square, becomes 0. Kinetic energy becomes 0 here, right? And kinetic energy becomes 0 means at that point, and while it is coming back to its original position, again it is possessing 150 joules of energy. That means the kinetic energy is turned into a type of energy which stores by the system itself, and when it is coming back to the original position, that energy is dissipating by the system, and ultimately the old energy, the kinetic energy, again we are getting, and the amount of energy, that kinetic energy 150 joules is stored in the system, is known as potential energy. And that potential energy is increasing or storing in the object by virtue of its position, by virtue of its position, right? And here, when kinetic energy becomes 0, the total amount of 150 joules is stored in the system as potential energy, is stored in the system as potential energy, right? Now the next point is, see here, the relation between, the relation between work and potential energy. Potential energy. See one most important point here. I told you that the object is storing the amount of energy, and while it is storing the amount of energy, the kinetic energy is going to be decreasing, and potential energy is increasing, and ultimately at the topmost point, potential energy is maximum and kinetic energy is zero. Kinetic energy is zero. Right? Now let us see a case. Suppose an object is present here. This object is thrown in the upward direction. Then the work done by the gravity is force due to gravity into displacement, and force due to the gravity is mg in the downward direction, and displacement is in the upward direction, and the angle between these two is 180 degrees. So minus mg h, and let us assume m is equals to 1 kg, 10, 2, which is equals to minus 20 joules work done for object to move from here to here is minus 20 joules. Now at this point, object's kinetic energy is zero and potential energy is maximum. Potential energy is maximum. When kinetic energy is zero, potential energy is maximum, and work done by the gravity is is stored in the system, and that energy, that work done, suppose for downward journey downward journey, work done is equals to force displacement. Mg is in the downward direction, displacement is also in the downward direction, and here 1, 10, 2 meters, and work done is equals to plus 20 joules. And again I am saying here potential energy is equals to 0. Potential energy is equals to 0, and work done is maximum. Work done is maximum. And again I am saying here work done is minimum, potential energy is maximum. Here potential energy is minimum and work done is positive 20 means maximum. Now by this conclusion, can I say that work done is negative of potential energy, negative of potential energy. So we can conclude that minus delta U, that is minus of UF minus UI. Therefore, W is equals to minus of delta F UF minus UI. Right? Then, next point, based on this concept, let us go through some examples. Right. A pendulum initially is at rest in a vertical position. The bob is pulled slowly towards right. Find the change in gravitational potential energy of the pendulum bob of mass m as a function of x. See here, if the bob is moving up to here, and how much would be the potential energy stored in the bob in terms of answer x, in terms of x. And clear in terms of x. Now potential energy is equals to potential energy energy is equals to mgh, and here by we are considering this as reference line. With respect to reference line, it has moved a displacement h, and mg is the force due to gravity, and work done is changes into potential energy, and potential energy stored in the system is now mgh, which is equals to theta, and h is equals to, can I write L cos theta? This is L. Then L is L 1 minus cos theta. So mg L 1 minus cos theta, right? Then from diagram cos theta is equals to, can I say this is equals to L square minus x square, L square minus x square by L. Therefore potential energy is equals to mgl 1 minus under root of L square x square by L. This is what is the answer, right? And this is the potential energy of the bob, right? Then let us go for the next one. A uniform rod of mass m, length L is held vertically upward on a horizontal surface as shown in the figure. Assume zero potential energy at the base of the rod. Determine the potential energy of the rod. Right. See here. This is the rod. This is the rod. And for this rod, mass is m. Total length is L. Right. Now, let us assume at this particular height dy, which is at a height y, then du is equals to dm into g by, and dm, let us assume it as equation number 1, and dm is equals to total mass by total length into length of the considered portion by using linear mass density concept. Then substitute 2 in 1, then du is equals to m by L g by dy and 0 to u, from 0 to total length L, right? Now mg by L y square by 2, 0 to L mg L square by 2L LL get cancelled, then the potential energy is equals to mgl by 2, and this is the potential energy stored in the rod when it is placed vertically upward direction. And see here, one more important point is this solution will also helps you as a concept, and whenever a question is present in the question paper that a rod is having in the vertical position, what would be the potential energy, and if that is changing, right? And you must remember, for a rod to be at vertical position, its potential energy should be equals to mgl by 2. As a formula also you can remember this one, right? And see, based on the same concept, I am giving you here a question, and as I told you, daily I am going to give you a homework, and today also I am giving you a question, and mostly you will try your able best to solve this question. And if you need any help from my side, let me know through the comment box. I will definitely try to give you the answer, and I am posting daily practice sheets in our telegram channel and weekend examination papers also in our telegram channel, and you can go through them, and once you complete your class work properly, means my class notes properly, then you better to go your worksheets. That will definitely enhances your knowledge a lot. Have a great day. Take care. Bye bye.